Okay, for this growth and decay maze, if you're good to go, you can just go. But if it's helpful, we're going to start at start here. You want to shade the squares with decay. And I'm going to remind you, we're going to do a more comprehensive notes after break, but exponential growth and decay happens. So let's talk about both of them. Your base has to be a positive value other than 1 for that to be exponential, okay? So positive value other than 1. And that would be growth and decay. We'll talk more about why 1 doesn't work after a break. But positive value other than 1 would be both growth and decay exponentially, if that's being raised to that x power. And then the other piece, if we're just decay, see if you can remember, just decay is going to be if your base is between 0 and 1. So decay would be if your base is greater than 0 and less than 1. Okay. Sometimes people think just if your base is a fraction, but if your base were like 3/2 to the x, that is not between 0 and 1. Okay. It's not just about being a fraction. It's got to be between 0 and 1. The other pieces you need to know here are, or just reminders, would be, excuse me, if I had 3/2 x, let's say, like to the negative x power, you want to think of that as 3/2 to the negative 1 times x. And you want to remember that a negative exponent is going to, you're going to find the reciprocal of the base. So you're going to turn that base into a fraction and flip it. So if I were applying, this doesn't apply to this one, that's different. But if I were applying the negative x power here, I would just take the negative 1 part out. Think of it negative 1 times x. I would take that negative 1 and just use that to flip it. Then I'd have 2/3 to the x, okay? And that would be example. I'd look at this and I'd say, is that base between 0 and 1? Yes, being raised to the x power, so that would be an example of decay. So as I'm looking at these two options from the start, you can't go diagonal on this, up, down, left, right. As I'm looking to the right, this base is not between 0 and 1. And there's no negative exponent that I need to simplify, so I'm going to shade this way, okay? This base is also not between 0 and 1. It's negative, which sometimes pulls people in, but remember we're defining that as a base between 0 and 1. Not true. But if I look to the right here, the base currently is not between 0 and 1, but think of this like a 3/1, and then that negative 1 in the exponent spot, I'm going to break that off and apply that negative exponent property and just flip this base. All right, so then I can more clearly see that this is, excuse me, an example of exponential decay. So I want you to finish that maze. You can pause the video, try it out, and then I will explain about the logs maze. Okay, for the logs maze, what do we need to know? Some negative exponent stuff will come up here. I'm just scanning this. We're not here yet, but if you get stuck on something like log of 0.01, turn that into a fraction. Okay, so 2 reminders, at least, that I know we need. Number 1 is I can turn something from log to exponential. Some of you describe this as like the circle method. It doesn't actually matter what letters I use here, but you're going to want to know you can always convert something from logarithmic to exponential form by saying this base raised to that opposite power equals, in this case, a. Because what a logarithm is representing, on its own, it's saying the base raised to what power equals a here. So like b raised to what power equals a. And since we've set this as an equation, we're like this base raised to the c power equals a. But let me get all that stuff off of it. You can just use this that I have here. Just like keep this up and remind yourself you're going to be doing a lot of converting to that form. So in this maze, you can go diagonally as well. So let's take this. We've got 3 to what power? 3 to the x power equals 81. Please don't use the log function or the log button on your calculator. Not that that's going to be super useful in this case, but you're going to want to make these the same base. So you might already know which power we're talking about here. 3 to the 4th power equals 81, but you can also rewrite this, the 81, as 3 to the 4th power, and then say I can set my exponents equal to each other. And I know that's the fourth power. Let's do one more because I want to remind you about rational exponents. So I'm going to rewrite this 8 to the 1/3 power equals x, right? That circle idea that people were talking about. Remember, in an exponent, the numerator is the power, so first power doesn't do much for us. The denominator in that exponent is the root. So again, without one of your graphing calculators, you should know that I can rewrite this as the cube root of 8. And I'm going to simplify that. So cube root is saying what times itself 3 times gets you 8. The answer is positive 2. So I'll go in this direction. Do your best on this one, work together, then hand that in when you're done, and go to whatever's next.